Okay, now this is where things start to get interesting. We've done work and we've pretty much understood what work done means. Exactly like what Newton taught us with uh, F net. We come now to the two definitions. The work energy theorem. Now, the work energy theorem states that work done on an object by a net force is equal to the change in the object's kinetic energy. That means the work energy theorem formula will equal the total work done will equal the change in kinetic energy, which means the final kinetic energy minus the initial kinetic energy. Okay, now this formula, K equals a half mv squared. It almost looks like this. Remember, this is momentum. This is energy. Now, we understand energy as the ability to do work, right? But now, a moving object that has a mass, so a moving object, a box that is moving, has a mass and has a velocity, we can calculate that object's energy. Now, depending on what happens to the box, if maybe it gets slower, there will be a change in energy, right? This is now how Fnet work can also be translated into how you can calculate an object's initial or its final energy. Now, the SI unit for energy is also the Joule. Okay, this is how all of these formulas now add together. Okay, I want us now to do an exercise. We're going to do an exercise that will show us how these formulas actually blend together. Okay, so I want to go here and then I want to add the question here. This is the question I want to add. Show you the question. Okay, let's put it there nicely. There we go. Now, a rescue helicopter is stationary and hovers above a soldier. The soldier of mass 80 kg is lifted vertically through a height of 20 meters by a cable at a constant speed of 4 meters per second. The tension in the cable is 960 newton. Assume that there is no sideways motions during the lift. Air friction is to be ignored. So the soldier is stationary, even though the stationary soldier is holding a rope, right, and he's hanging. The shoulder is stationary. Now, state the work energy theorem. Okay, what did we say? What did we say the work energy theorem was? Let's go back. Or let's do this. Let's try and Let's try and add this. Okay, let's do this. Hold on, sorry about this. Yeah, so I can try and answer. Okay, number one. The work energy theorem states that the total work done is equal to the object's change in kinetic energy. That's your 2 marks right there. Okay, that's your 2 marks. Okay, draw a labeled free body diagram showing all the forces that are acting on the soldier while being lifted. Okay, so we go number 2. This is the soldier. There is tension here, tension force. There is weight. Over there. This is the soldier. That's the rope the soldier is hanging on of 960 newtons. And then we can calculate the weight. 90 kgs times 9,8. Then there's a force of 882 newtons acting downwards. Correct? Great stuff. Write down the name of the non-constant force that acts on the soldier during the upward lift. It must be air friction. It must be air friction. Okay, now use the work energy theorem to calculate the work done on the soldier by the friction after moving to the height of 20 meters. Okay, so the soldier is moving up. Soldier is moving up. Go to my page here. When I erase all of this, I think I need all of this space. Okay. The soldier is moving up. So we're gonna say F net is equals to change in energy, kinetic energy. Right. What is a F net? So that is work by the tensile force plus work by weight, which is gravity, plus work by friction, which is equals to the change in kinetic energy. Okay. Is change in kinetic energy. Sorry. Okay. So now I can say that F plus change in y cos theta of the tension plus F plus change in y cos theta of weight plus work of friction is equal to 0. Okay, then we can say 960 multiplied by 20 multiplied by cos of 0 plus, what was our weight? It was 8,820. 9,8 times 90. 8,820. 882, sorry, multiplied by 20 multiplied by cos of 180. Remember, weight was acting directly opposite the tension force. And then plus work of frictional force is equals to 0. Because now the soldier is moving vertically up. Okay? So now we calculate that 960 20 cos of 0 is equals to 19,200, sorry. Then my weight, 882 multiplied by 20 multiplied by cos 180 is equal to negative 17640 plus work friction is equals to 0. Okay. And now, what am I going to say? I'm going to say that work friction is equal to 17640 minus 19,200 equals 9,200 equals negative 1,560 joules, because the frictional force acts negatively. Okay, I'm happy with that. Okay, identify the two forces which do the negative work. That will be the frictional force and the normal force. They act directly opposite all of this. Okay, great stuff.